I appreciate this because this is of course a very timely topic and something that we need to be discussing and trying to understand how things are changing. Sorry, there we are. And when I think about these issues of change in the climate and change in how that's going to affect production agriculture, my ultimate concern always comes down to the farmer, right? I mean, so if we think about if something's going to change in way which we perform our operations, we need to know about it. We need to understand what that change is going to look like. We need to understand if it's systematic or if it's like a one-off change, and define it in a way that allows us to better predict maybe the future behavior of how things are going to change. So what I'd like to do is I present to you what I understand about our changing climate. Is I'll let you know something. Today, I'm not going to show any projections, any future projections. We're going to try to learn about what we expect to happen in the future by just studying what we've already collected in terms of data and understand in the past about Earth, which you can see kind of rotating in the background there. Now, when you're thinking about climate and changes in climate, I want you to think about it as a source of risk, because we know that weather variability and variability in climate and trends in climate do pose a risk. They could change the way we do business. But I want you to think about it in terms of this figure that's over here on the left. Now, of course, 2020 was unprecedented for a lot of reasons. And if we look here at the performance of the S&P 500 going all the way back here, gosh, this is going back into like the 1930s, we can see here that overall there's this beautiful systematic trend that goes up like this, right? So we step back away from it and we can look at the data and just say, you know what, since this time period began, we've noticed this increased value of this particular index. In this case, it's due to financial markets. But sometimes it's very difficult to be able to separate the here and now. Like this is what happened when we saw COVID being announced, and then this is the recovery after. This is what happens when we try to understand the highly variable nature of the here and now versus the long-term systematic changes. And what I'm going to talk to you about today is more of what you see over here on the left and not the weather stuff that you see over here on the right. Yes, it's financial markets, but weather is basically the day-to-day highly variable weather conditions that we all experience. It's the fact that yesterday all the ice melted finally off my trees and it got nice and warm, and then we're expecting possibly at the end of this month a major shift in temperatures. But climate is the background trend in all of this. And ultimately the reason why I study it is to understand if anything is systematically shifting, that's going to change this map. So the map you've got here in the background shows you different land use type across the planet. And I want you to focus in right here on this color. I'll draw a white arrow to it, that cropland color right there. Because if we see changes in that cropland color, in its area extent, if we see changes in what's grown in that region, we didn't understand why and how and what it's going to do to kind of our global production of food and fiber, right? Now, I do want to spend just a moment explaining to you what the latest scientific evidence is of why the climate is changing. And it comes down to this. We've been observing Earth and its atmosphere for a very long time. And we study those things that make Earth's atmosphere habitable, that make it so well adapted for growing crops and for the thriving of a human population. And it's basically because planet Earth is just the right distance with the right composition of gases in the atmosphere, closest to our nearest star, but not too far away. And as a result, we end up having this very habitable temperature profile. One of the things that makes that temperature profile of the atmosphere habitable is the fact that we get water in all three phases in the atmosphere, water vapor being a critical phase of that. In fact, water vapor, when you combine it with other greenhouse gases like carbon dioxide, actually keep Earth much warmer than it would be given our distance from the sun. It's the natural greenhouse effect. It's what makes planet Earth survivable. Well, we've noticed since the Industrial Revolution that we've changed the concentration of one of those greenhouse gases, specifically carbon dioxide. Others have changed as well, but what you're watching in here is our systematic measuring all over the world of greenhouse gas concentration, specifically carbon dioxide. And carbon dioxide is a critical gas in the atmosphere that retains heat and makes Earth livable. But if we change its values ever so slightly, it has a better ability to either retain heat or not retain it. If you increase the partial pressure of a greenhouse gas, you will increase the frequency and the potential, basically, of its ability to retain that heat. And as we watch that change in this particular figure, we look back at how, well, greenhouse gases, specifically carbon dioxide, have changed. The most dramatic changes happened since the Industrial Revolution. Now, thinking about all of that, what I want you to understand is that when we think about these changes in these gases, we have to remember that as they're distributed all over the planet, that the effects of the warming are not going to be uniform. You see, the most dominant greenhouse effect, water vapor, blows around with the wind, as you can see here. And as it's moved around and as the temperature warms, we're changing the concentration of water vapor. We're changing a lot of things about the composition of the atmosphere, basically making it better at retaining heat. We can see evidence of this by looking at a lot of places. For example, earlier this year, I was watching very carefully Arctic sea ice extent. That's the figure that's over there on the right. Normal sea ice amounts now are far outside of the typical range they had been in for the last 40 plus years. And so we start to understand how this regional variability is playing out on ag. And all that I want to do to you today is not spend time telling you about the science of a changing climate, but I want to show you the evidence of the change and then start to understand what that might mean for production ag. So let's get into some evidence here. We've been observing global temperatures, and the figure that is on the left and the map that is on the right are not in dispute. What they show you here is the change in temperatures going back to the end of the Industrial Revolution. What we've noticed is that since then, there's been overall a global increase in temperature by about a degree Celsius. Now, that may not seem like much, but here I am sitting in Mahomet, Illinois. The ground is very flat in this part of the world. I'm sure you all know that. Part of the reason for that is we don't have any nearby plate tectonics taking place. And secondly, about 20,000 years ago, the glaciers scraped this place flat, and then we got a bunch of good soil that blew in on top of it. Now, when those glaciers sat on top of where I am here in Mahomet, filling the Mahomet aquifer from which we get our water, we had a global average temperature that was about 4 degrees Celsius colder than it is today. So the point behind me telling you that story is for you to understand that the 1 degree increase we've seen just in the last 150 or 200 years is substantial when you think about Earth's thermostat. But as you see over there in the figure on the right, that change is not uniform. It tends to be more focused, especially in the Northern Hemisphere. Now, from there, I want to show you one of my favorite figures to show you when I talk about climate change. And it's this one. It's a distribution of temperatures across North America. What you're about to see in animation is how that distribution has changed since the 1950s. So what we watch here is the median and the mean and the mode. We look at the tails, and what we have seen over the last, 50 plus years is a systematic shift in that distribution toward warmer temperatures. But as I've been telling you, the distribution is not uniform, for example, across North America. But what this essentially tells us is the probability of us having more high temperature events with moving the mean in this direction, as you can see, has changed the shape of the way that the temperatures behave across North America. And even though you may see when you look at this, that the tail looks as though it's kind of collapsing, it's not. It's actually still extending out here into these -3, 4, 5, and 6 standard deviation events. We have flattened our distribution of temperatures. And what I want to spend some time talking to you about today is what this means not only here across North America, I also want to talk about South America. We'll even toss a little bit about Canada. And we'll see where else we can end up by the end of the time we have today. So with that as a setup, this is where I want to get to. Some research published in the journal Nature. That graphic that you see running across the top there shows us over the last 70 years how we have seen and observed systematic changes in the position of the jet stream. Now, this is a great concern because the western part of the United States is critical to global agricultural productivity. It's highly variable in what they grow. There's a lot of varieties, and California is at the epicenter of the changes you see here. Now, what do the colors represent? If you look here across the western part of the United States, whoops, let's switch that over to a black color. You see here that there's more, the red colors are in place, indicating that in summer, we're getting more ridging events that happen across the western United States. And as a result, looking over the time period of June through August, going back over the last 70 years, the Western United States has seen in its average temperatures about a 2.5-degree increase in temperature. You can see it again right through there. And what's interesting about that is that increase of temperature in summer for the West, which is their dry season, has made their dry season even drier. And there's been some long-standing research that's trying to understand this. This is some of that research. It looks at what's called California's vapor pressure deficit. Now, what does that mean? Vapor pressure is the partial pressure of water vapor in the atmosphere. It tells us how much moisture there is. If you are building or increasing a deficit, it's getting drier. And you can see that lately, the vapor pressure deficit's been increasing and it's forecast to continue to do so. Now, what does all that mean? That means the dry season in California is getting drier, increasing evapotranspiration rates, greater pressure on their agriculture. And we saw that in great evidence in 2020. You've got two maps here. The one on the left looks at the entire year of 2020 and compares it to the 129 years of data we have across the United States. The closer you are to the number 1, the hottest, closer you are to 129, the coolest. Now what you can see here is that across the West, there's a lot of single digits out there telling us that we had a very, very hot year. And with the increased temperatures, we also had a lot of drying. And many of the reporting districts across the Western United States are just finished one of their top 5 driest years on record. While much of the Southeast was extremely wet due to a lot of hurricane activity. We'll talk about more about that in just a few moments with climate change. In the Midwest, sandwiched in between, we're going to discuss that too in just a few moments. But I want to be very careful about something here, because I told you at the beginning, a lot of times people tend to conflate the ideas of changing weather and changing climate. Let's not do that here. We're just using 2020 as an example in a longer term record of change. But it did get very, very dry throughout August, September, and October in the West. And we'll talk about what it did in the Midwest here in just a few moments. But just to be clear, the reason why was that the jet stream built into a large ridge there. Now, why tell you this? If you go back to that paper I showed you a few moments ago from the journal Nature, it is more frequent to see big ridging events across the West in summer. So this is following the longer term trend. Although in this particular year, what led to this was the fact that we had a developing La Nina and the jet stream just took off to the north and never came back. It looks something like this. Midsummer jet stream flow. Large area of higher atmospheric pressure set right here, and the flow just went around it. Big, what we call ring of fire set up, lots and lots of thunderstorms running around the periphery of that big ridge. But those thunderstorms are often what we call dry thunderstorms, which means they produce a lot of precipitation that never makes it to the ground. It evaporates first. So the lighting from these storms starts a lot of fires. This was September the 6th. What you're looking at here is the prolific coverage of the smoke from the wildfires in the western part of the United States. I'll show you this fire in particular, the Cameron Peak fire in Colorado. Airplane flew very close to it and got us a beautiful view here of the smoke. That smoke blew across central Illinois. We had an incredible sunset because of it. In fact, it didn't stop in Illinois. It actually blew clear over into the open Atlantic, and some of the smoke from that wildfire was found 5,000 miles away in the North Atlantic. At one point after Labor Day weekend, the snow blew, excuse me, not the snow, not thinking about snow, but the smoke blew out of the east toward the west, covered San Francisco. What you can see in this particular picture here, midday, almost all of the direct sunlight completely blotted out here by the smoke, and all you got was the indirect light, and most of that was just the red and the orange that could still survive the path through the atmosphere. Here's what we've got from Santa Rosa, California. You can see pictures of the ash from this year. Remember, a couple of years ago, Santa Rosa was nearly burned to the ground. Now, when we think about this, I want to tell you something about California. I'll leave it on this slide to make my point. California leads the nation in the production of over 40 different fruits and vegetables and milk. California's water resources are already tight because there's 40 million people. And they get their water from melting snowpack in the mountains, which right now, the Sierra Nevada, are already through early January over 100 inches in deficit in snowpack. They get their water from aquifers, but the groundwater levels in California, compared to what they were just a half a century ago, are in some places 1,000 to 2,000 feet lower than what they were. That's right, some of the wells dug in California go down 2,000 feet before they hit water. And the other thing about California is they do have river systems that bring in water, but the water on those river systems is so tightly controlled that oftentimes it's just not enough. My concern over California is that with time, there's questions about whether it will be able to maintain its agricultural productivity because of the water stresses. And that's something that I think all of us in the agricultural industry are very concerned about. And there's a lot of evidence to support it. But from the West, I'd now like to come back east and talk about how the systematic changes we're seeing in the West are actually impacting this. What you've got here is a very familiar map, I think, to everybody on this call. It's county level corn production. And what I do is I color coded the counties here to represent how much they grow. Illinois, we have some of the biggest counties producing a lot of corn. In fact, McLean County is routinely the top corn producing county in the United States. When you look at this though, I often want to understand how weather and climate impact that map. So what I did is I made this one for you. It shows you variance, taking USDA county level survey data on yields. I went back to 1980 and I calculated the year-to-year variance in corn yields and color coded it. Now the bluer colors represent very low year-to-year variance. And we would expect to see that in the places you can see it on the map, because those are regions where we have irrigated farmland. And therefore variance is low when you can water the crop whenever you'd like. But look at the Southeast, look at the lower Mississippi River Valley, the Delta. Look at parts of Texas, Missouri, eastern parts of Kansas and Nebraska, and they get up into the Dakotas. Those regions all have very high variance, whereas the primary corn and soybean belt from parts of Minnesota through parts of Illinois, Indiana, Ohio, Michigan, and Wisconsin, we see pretty much normal variance for the corn belt. In some places, we resist a lot of change. But I want to come back to this figure too, one you've all seen. From 1980 to 2019, we're looking at corn yield. And the question that I get asked is, we've got this incredible upward trend to the tune of about 2 bushel per year for the whole United States. It's a technology trend driven by seed technology, planting technology, and the ability for the crop to be efficient at taking in nutrients. Any variability that's around that average is often due to weather. And we have, of course, some important years on here, like the one that you see over there, 2012. That's my hand holding an ear of corn that I pull out of a field in Douglas County. A good friend of mine named Jerry and I were out there scouting. And I said, can I take this home? He says, yeah, I don't have any use for it, because that particular field that year only hit 85 bushel an acre. This past year it hit 245. So drought issues like this are of great concern. So I begin to ask these questions, like we just did for the West. Are we seeing systematic changes in temperature and precipitation? And we'd better talk about it if we are. Let's talk temperature first. Across the top, I have 3 different figures. This is for the primary corn and soybean belt, but Illinois' numbers look very similar. The maximum temperature, see it over there on the left? Well, because the West in summer is ridging more often than not, they're taking on the heat. The maximum temperature trend across the primary corn and soybean belt is actually flat, even slightly decreasing. Now, what does that mean? That does not mean that we can't have years where the summer gets really hot. Years like 2012 will still happen, but the frequency of extreme heat events in the Midwest over the last 70 years has actually gone down. Where have we added heat? It's in the middle figure. Overnight low temperatures. We've increased our overnight low temperatures up to the tune of about 2 degrees. When you look at that combined, the average temperature for the Corn Belt has increased about a full degree Fahrenheit. Now, why this is of concern is because the figure that's down there in the bottom left, I made it a couple years ago, but it still holds true today. On the y-axis of this figure here, you have yield. And on the x-axis, you have bushels per county. And every single gray circle there is a different US county that grows corn. Now, everybody talks about the I-states all the time. Here they are, and I labeled them here. I'm a big-time Big Ten basketball fan, and I didn't leave out Indiana University on purpose. I left Purdue in there, but it doesn't matter. But you can see that the counties in Illinois, Iowa, and Indiana populate the top side and the right side of this graph. And it's a graph I've shown this group before. And right over here is McLean County, by the way. Now, I asked myself, are the temperature changes that we're observing going to change the productivity of these counties? And my answer to that is, right now, I would say that it's changing it in a positive way. And this is why. We have actually seen a pretty significant and systematic increase in the length of our frost-free season, to the tune across the state of Illinois by about 9 days. Data from the EPA over there on the left and the US Climate Assessment over there on the right, both of these are peer-reviewed articles, show you that we've added, on average, about 9 days. And most of those earlier days in our frost-free season are coming in April. They're not coming in October. So we've brought back the last frost, but not changed the first frost. Does that make sense? So when I see that and I see a net positive effect, I then begin to ask myself, are changes in precipitation getting in the way? And to answer that, I'm going to show you this figure. So on the left is 2019, on the right is 2020. And what you've got here is the way that September through October finished in 2019 versus the way it was in 2020. Now, two very distinct and very different years, right? We finished the end of 2020 with extremely dry conditions across the Corn Belt. In fact, in August, Nebraska had its driest August on record. Iowa had its third driest August on record. Illinois had its 13th. And then everybody went over dry to finish. But in 2019, extremely wet kept us out of the fields harvesting quickly. In fact, we didn't even harvest most of the crop in the Dakotas because it went in so late and didn't come out. They harvested it this past January. That's when they finally got in there and saw that. I don't need to remind anybody how bad 2019 was, but over there on the left, I took a trip to St. Louis to see the Mississippi River in June. And you could see how far it was out of its banks. And some of the water made it up there 3 steps higher on the steps to the arch. We would have been setting a new record. And I've been showing this picture. It's one of my favorites here. This was, that should say 2019, not 2020. But over here on the right, this was July 9th, 2019, here in Mahomet. And that's my son. He was 6 or 7 at the time, and or almost 7 at the time. And the corn there was planted in late June. And he asked me why I was taking this picture in front of the corn. I said, son, normally when out here at this time of year, the corn is twice your height in tasseling. But this particular year, because of all the flooding, didn't get there. What did we get in 2020? Flash drought. Good friend Chad Colby was out flying his Cessna. Got this incredible picture here of one of the field fires we saw here in central Illinois, over toward Bloomington, that we had back in at the end of our growing season. And on the right here, this is up in Minnesota. This is when a fire swept through a field here, burning off everything except for what's left there of the stalk and the ears of corn. Now, I appreciate the humor of the guy that did this. He did go out and try to harvest that corn, but it was cooked, but at least the moisture was down to 3%. Okay, let's talk now about precipitation variability. What these next figures are going to show you is, for April to October, across the primary corn and soybean belt, we have observed, on average, during our growing season, a 5.5-inch increase in total precipitation. That's a lot. You increase the length of the growing season, add more rain, we would expect productivity to increase substantially. But something else is going on with this increase in precipitation. We're getting a lot of variability in it. Over there on the right, in the state of Iowa, looking back over the last 40 years, using data from the PRISM data set, which is the highest resolution precipitation data set we have across the United States, we find that the daily frequency of 2-inch rainfall events per 24-hour time period over a year has tripled in Iowa and doubled in Illinois, which means the increases in precipitation that we're observing over the whole of the growing season tending to happen in much bigger helpings, followed by, well, flash drought situations where it just gets dry. Now, thinking about that, I'll never forget a conversation I had in 2019 with a farmer down in Effingham, Illinois. He's an older guy. He'd been farming for almost 50 years. He was in his 70s. And I just finished talking to a group of farmers, and he came over to me and goes, you know something that's weird? And I said, what? He goes, last weekend. I said, what was weird about last weekend? He goes, it rained all weekend. I said, yeah. He goes, when's the last time it's done that? I said, what do you mean? He goes, we don't get rain for a whole weekend anymore, right? I mean, these nice soaking rains where you just pick up, a 1/2 inch a day. He goes, all the rain comes in like 10 minutes now. And I thought it amazing to hear this man who's been farming for 50 years share with me his anecdotal evidence of the data which I process every day. And when we think about that, we have to understand what this is going to do to the US farmer, increasing variability in precipitation. I'll tell you what the numbers look like for Illinois. Just You can ignore the figure on the right, it's just the evidence of this. But look what I wrote over here inside of the outline of Illinois. I looked specifically at April and May. I wanted to understand two things. What is the change in frequency of our 1-inch rainfall events in April and May? And what is the change in frequency of all rainfall events in April and May? And then how long does it keep us out of the fields? Now, you know that the USDA has a calculation that they, or excuse me, not a calculation, but a metric they give you on number of workable field days, right? It's based entirely on survey results, so there is no way to calculate it. So I went out and talked to some farmers about what happens when you get a 1-inch rainfall event. And from that anecdotal evidence, plus the research I did over here on the right, I've found that in April and May, for the state of Illinois, since the 1980s, we've lost approximately 5 days that we can get out and do field work because of increased rainfall. In other words, we're shortening up, we're tightening up our planting windows. And we've been able to outpace this, right? We've outpaced it with technology. We got bigger planters that plant faster. So when the windows open up, we get in and get things done. But the reality of it is that this is changing. In fact, let me put a point on this West Coast versus East Coast thing. This graphic over here, one I've been showing for a couple of years now, but it holds true to present. When you look at two different time periods, the years 1981 to 99 versus the years 20 to 2018, both of those are 19-year time periods. Get west of the Continental Divide, systematically, it's been getting drier. East of it, we've been getting wetter. And I'll never forget this Twitter exchange I took part in. I observed, I should say. This guy by the name of Andy tweeted out a question, young farmer, March 28th of this year. What on-farm investment has the highest ROI? Now, it was a bit funny, some of the replies. In fact, one of them says the biggest ROI is just to marry rich. But outside of that, the most common answer that he was given was to invest in pattern tile. And that was because when we have the water, too much of it, we need to make sure that we can get rid of it and keep that soil healthy. That was a very interesting bit, again, anecdotal evidence of the research we're doing. Let me add more to this for the state of Illinois. I then wanted to know, are we changing how much moisture is in the atmosphere? And I'm gonna look at it in two different ways. First is with a quantity called precipitable water. Now, why would we look at that? The measurement of precipitable water tells me how much moisture is in the atmosphere that can get rained out. Because we're getting these bigger rainfall events, are we seeing some sort of systematic change in that? And since 1970, what we have seen here across the state of Illinois is that there's a significant increase in it, to the tune of about 15%. Now, because of that, we've actually added the amount of moisture in the atmosphere, which in turn retains more heat. You all know this, a cloudy night, a night with high humidity, doesn't get as cold as a night that's cool and dry and clear. And so this has corresponded to an increase in minimum temperatures of about 3 degrees. And that's what you see down there in the embedded figure on the right, the correlation between these changes in temperature and the changes in precipitable water. We can bring this to a more common term, relative humidity. I did the same graphic here, but instead looked at relative humidity. Just look over there at the numbers on the left. Since 1970, we've actually measured a 6% increase in relative humidity across the state of Illinois. And those kind of changes are observed. This is not something that I'm projecting, it's what we've observed. But we come back to our question, is this good or bad for agriculture? And overall, we can say that the net effect of this has been beneficial, simply because in Illinois, we have the soil that can handle heavy rainfall. We have the technology, especially in pattern tile drainage, that's been able to take care of some of the excess water. Not as though it doesn't hurt, we still have problems, but we've been able to kind of absorb the changes and be productive because of them. But I'll make a point here. Into the future, one of my favorite videos I found last year, we're gonna have to be thinking about ways by which we can better manage our water. I think this is gonna be critical for the state of Illinois to continue to invest in water management strategies. In fact, it reminds me of a great book I reread this winter. You all know about the Dust Bowl of the 1930s. So much of what happened in the Dust Bowl of the 1930s was due to bad land management. In the western part of the United States and in the central plains of the United States, it was common thought at that time period that in order to prevent erosion, now get this, in order to prevent erosion, you plowed your fields. Every time it rained and you didn't have a crop in, you plowed your field to turn the water over and keep it in the soil. Now, these were incredibly bad practices that we know better than now. What I love is the story about Hugh Bennett. Hugh Bennett was a major soil conservationist and he petitioned Congress during the socioeconomic disaster and weather disaster of the 1930s to basically form something called the Soil Conservation Service. There's a great story in that when he went just 5 days after what's called Black Sunday, that was the biggest dust storm that ever moved across the United States, he went to Congress and was testifying. And while he was testifying in front of Congress, what he was doing was he was making a case for why they needed to give funding to agriculture and to support soil conservation. In the middle of his speech to a dreary-eyed Congress, his aide tugged on his pant leg and said, "Hugh, listen, we have one of our dust storms coming out of Kansas, and we've got reports of it coming all the way toward the Appalachian Mountains and maybe to DC. The reports are maybe here in an hour." He says, "Can you stall?" And Hugh Bennett says, "Oh yeah, I can stall." So he starts showing charts and graphs and starts, making this big story about how things were changing in the West, in the Midwest, in the Great Plains, and we needed to have relief for it. And he built his talk up into this huge crescendo just about the time that outside the dust arrived over the capital city. The senators who were asleep, they woke up and they walked over to the window and looked out on the coppery hue of the sky as it got darker and darker. And Hugh Bennett, in his big booming voice, comes up right behind them as they're all staring out the windows. And he says, "This, gentlemen, is what I'm talking about. There goes Oklahoma." The next day, the Soil Conservation Service was started, fully funded, and everything began to change. Now, you've been watching this poor guy here use a 5-gallon bucket to toss water over a fence, and I love this video. But the point is, I want to make sure we're not doing practices moving forward that are as useless as this or as useless as plowing every time it rains, right? So we need to think about this, engage with the universities, engage with industry, to learn the best practices so that we can engage with farmers. This is exactly what Hugh Bennett would want me to tell you. Now, from there, I'd like to talk about severe weather. 2020 gave us some pretty nasty storms at times. This was probably the worst for the state of Illinois in terms of straight line wind damage. Now, the question is, are we seeing a trend in severe storms? And I have no answer for you. The research is largely inconclusive, and the reason for that is because we are just on the precipice of studying it in great detail. But the fact of the matter is, nasty storm systems like the one that you see there that came through Illinois, this is in Pontiac, laid our corn flat. And sometimes these big storm systems that produce a lot of rain and strong winds can really be detrimental on a local level. Now, this past year was punctuated by this event. This was the Derecho event. Frequency of big windstorms like this one, well, they're quite infrequent. The last time we saw a Derecho event, which is just a long damaging squall line like this one that went across parts of Iowa and Illinois, last time we saw something of this magnitude was back in 2011, before that in 2008. They don't happen that often, but when they do, they produce a lot of damage. Cedar Rapids, Iowa here, picking up wind speeds between 100 and 130 miles an hour, and much of Iowa looked just like this. Corn and soybeans laid flat, infrastructure destroyed. And the end result of it was when we looked down on satellite after the event was done, we could identify from outer space something like 8.5 million acres of destroyed cropland. Keeping on this theme of moving east, I would now like to talk to you about the southeastern part of the United States, because 2020 was extremely wet for them. We ask why. My earphones pulled out there. We had 20 separate tropical systems, 30 separate tropical systems that formed across the Atlantic this year. 12 of them came through the southern and southeastern part of the United States. We went 9 letters deep into the Greek alphabet, getting all the way to the Greek letter Eta. Not Ada, iota. Almost forgot there. At one point in the middle of September, look at this, Sally, Paulette, Renee, Teddy, and Vicky all cranking up there. Laura was probably the worst, and as it slammed into Louisiana, which Louisiana got hit 3 times this year, Laura's winds at about 1,000 feet above the ground hit 170 miles an hour. At the surface, 138 mile an hour wind gusts ripped the radar off of the top of the tower here. That's a $30 million price tag we're trying to pay for right now to get that radar put back up. Flooding was the problem though, and this was Tropical Storm Eta as it went through parts of Florida. The persistent rain bands here produced massive flooding, not only here, but all the way up to North Carolina eventually. And one of my favorite videos from southern Florida was that sometimes People that have a lot of money may not have very much common sense. And this guy here driving this Lamborghini is plowing through water. You drive a wedge-shaped car into 3 feet of water, it's going to go right over the top. But lucky for him, the engine's in the back, so it probably didn't have that much flooding into the engine. The worst was Iota. This was the last named system of the year. It was the most powerful, I should say. The worst for the US was Laura. But when we think about all these hurricanes and talk about climate change, I want to give you this statistic. My colleague and friend, Dr. Ryan Maui, has been collecting and publishing results about hurricanes for decades. And what you can see here is the work going back to 1980, looking at the top line there, which is all hurricanes globally. So this includes typhoons and cyclones and things like that. But on the bottom, we have major hurricanes, those being category 3, strength and stronger. Globally, over this time period, about 40 years, we actually see a very slight decrease in the number of tropical systems. Many of them not in the Atlantic, but in the Pacific. But when our hurricanes reach major status, category 3 and stronger, they tend to be more frequent. And what I mean by that is, with global ocean temperatures being warmer, with wind shear being less, we tend to find that when these hurricanes form, they get big and bad quickly, and the research would support that. There is a lot of very vulnerable agriculture along the Gulf Coast and East Coast of the United States. In fact, earlier this year, I had a phone conversation with a farmer friend of mine in North Carolina who has lost 1,000 acres to seawater inundation. This map here, which is down there at the website at the bottom, coast.noaa.gov/SLR, shows you where we have sea level rise and saltwater inundation problems. So it's a great resource that's down there. But from that point forward, what I think we should talk about here are changes in ocean temperatures. This year we saw La Nina. This is just developing through mid-November. I just left this old animation in there. What I'd like to share with you, though, is something very unique about this La Nina. Normally, when La Ninas show up, the cold water, which I'll draw in blue, tends to extend over this whole region. We tend to get cool all in this area. But I want to show you some interesting research. This embedded figure down here at the bottom shows the ocean temperatures right here, okay, in this part of the North Pacific. Over the last 40 years, the upper ocean heat content in that area has increased, such that even a cool episode is still well above the mean, which is right down here. If there's continued changes in the ocean temperatures here, guess what the jet stream's going to do? Watch, ready? It pushes it up in the west and troughs over the east. This is further evidence to support that the changes I explained to you for the Midwest and the changes I've explained to you for the West are going to continue to be the case. And La Nina events, like the one that you see here, are going to continue to struggle to bring that colder water farther to the north. And that's significant, not only for us in the United States, but also for our Canadian friends. Some very quick research on Canada. What you've got here are the observed seasonal temperature changes coming from, again, a peer-reviewed article out of the Canadian Environment and Climate Change Group that show for winter, spring, summer, and autumn systematic warming. Now, here's something to think about for Canada. If they are warming and increasing the length of their growing season, and they've also seen about a 20% increase in total precipitation, they're going to take advantage of the plains and the prairies of Canada to grow more and more and more food and feed. And that's a systematic shift to the north that is something we should all be paying very close attention to. It's changing that second map I showed you at the beginning of this presentation. From there, I'd like to talk about South America. Now in South America, we have a very interesting thing to think about here, in that South America currently only farms about 8% of its arable land. I put the state of Texas inside of the state of Mato Grosso. And Mato Grosso is one of their biggest producing states in South America. Now, the increase in acreage that's been observed since the late 70s, there's a bit of a misnomer about it. A lot of folks will tell you, oh, they're just cutting into the Amazon forest. And yes, that does happen, and it is happening. But the vast majority of the increase of acreage in South America is coming from the conversion of pasture land over to farmland to grow soybeans, corn, and cotton, and other crops. So their productivity for soybeans is exponential, as you can see right here. But there's some interesting things happening in South America. And I want to tell you about some research published in the journal Nature. So kind of like the West Coast of the United States, South America has a very distinct wet season and dry season. Their dry season is during our summer. It's their winter, August, September, and October. Now, the research I would like to present to you shows that since 1979, there's been a systematic increase, just like in California, of the vapor pressure deficit. And over that time period, I reconstructed that research using a different data set to prove it. That's what good science is. And I found that in the month of October, they have lost, on average, about 1.5 inches of total precipitation when the monsoon's supposed to start, give them the rain they need to get the soybeans germinated. This is shrinking the growing season for the first crop of soybeans and subsequently the safrinha crop of corn and cotton. This year, it reared its ugly head. In Mato Grosso, which is where I put that black box, I'm sorry, this isn't through mid-October. This is now through the beginning of January. Okay, I updated this figure this morning. What you've got over there on the left, follow with me. Over the last 180 days, they should have come out of their dry season right about here and started to increase precipitation totals like that. 2020 into 2021 is the solid black line underneath that yellow envelope. Mato Grosso is currently sitting at about 20 inches in deficit of rainfall. And going back over the last 40 years, this is the driest such time period in the CPC data set. That's where this is coming from, the Climate Prediction Center, the CPC data set that we have on record. It delayed the planting of their soybean crops. And they did eventually make it up, but I left this particular figure in there to show you that they spent most of the season about 30% behind normal on their planting progress. Just like in the Midwest, they're also seeing an increase in precipitation frequency of big events. In the state of Mato Grosso, there's been a doubling over the last 40 years of their intense rainfall events, 2 inches or more. And we can see here that Mato Grosso, let's get that arrow off there, is about 30% of their total productivity for soybeans. Now, just because I know a lot of you on the call are probably interested in knowing this, I will at least give you a near-term forecast. Mato Grosso is now into its 5th such extended dry time period. And it is going over wet, not only now in the next 2 weeks, but possibly through February as well. And therefore, as they go to get the first crop of soybeans out, which is already delayed, there are chances that the heavier rains, where they may get an extra 5 inches over the next month, could delay harvest. And that's something I want everyone to be watching very carefully. In my last few slides here, what I would like to show you is what's going on in Australia as well. Now, 2020 was an incredible year. 2019 into 2020 was an incredible year. We saw these massive bushfires in the southeast. And that video that you see there shows you where the smoke blew across the Pacific Ocean. Also, about a year ago, back on December 18th, 2019, get this number, you ready for this? When you averaged every temperature reporting station across Australia, they measured an average continental temperature of 107.4 degrees. Major concern about increased drought pressure and also increased pressure with heat. But by the same token, they still sometimes get these massive flooding events. The Toowoomba floods of 2010 to 2011, which was the last time they had a massive La Nina event other than this year, produced record flooding. This is where some rain from a nearby thunderstorm was going through a ditch. Let me fast forward a little bit for you. This is how things looked very shortly thereafter. The reason why I'm showing you this in the video over here on the right, which was just a few weeks ago, when a massive hailstorm punched holes in the ceiling of this woman's house. You'll see how big the hailstones are outside. These kind of major increases in precipitation variability are happening across Australia as well. And the research from the Bureau of Meteorology shows that the long-term changes in Australia are pointing toward much warmer conditions and wetter conditions where they don't need it here, but drier conditions where they have a lot of their agriculture. Now, I told you I wasn't going to show you any forecasts, but I want to make you aware of something very important that's happening within the agricultural industry. Especially with the change in the administration, we will likely start to see more legislation that moves toward solutions for climate change scenarios. And as a result of that, the US farmer is going to be seen as a source of the solution. The reason why? Modern agriculture is becoming less energy intensive and it's getting more efficient, and growing crops is a great way by which to store carbon. Now that is a sweeping statement that covers an entire body of decades of research. But I want you to be thinking about this more from the economic impacts of a changing climate. Because my second to last slide here is going to show you this one, which looks at the projections of how climate change is affecting things. And one of the things that a lot of companies are doing is they're trying to figure out how into the future the carbon economy will evolve and what will it mean for the farmer. Will it be something where the farmer sees this as a new opportunity, a new emerging market by which to prove sustainable activities and therefore have a premium? That's one big question that a lot of us are trying to answer. But the question will be ultimately, what direction does the whole planet take in terms of its, well, pathways moving forward? Are we going to take the business as usual? Are we going to start to pull back, change things? Will natural market fluctuations change our behaviors? Because if it doesn't, this is the best projection that I can share with you. This is from the US Climate Assessment. It's looking out over the next 80 years. And it's showing you where we expect things to get wetter and where we expected things to get drier. Notice a few things. Much of Europe going over to drier. Across the United States, the South and Southwest is drier. But here in Canada, in the Central Plains, into the Midwest, wetter conditions. Brazil, concerns over drier conditions. Australia, South Africa. But look at China and India. You see, this is a critical question to be asking, because as we look forward into this, we try to answer these questions for our industry, they boil down to a slide like this. And that is, what do the trends tell us? What do we think is going to happen based on fundamental and sound science? And how can we make plans according to that? Now, I've eaten up 50 minutes of your time today going through all of this, and we covered a lot of stuff here. What I want to do now is I want to stop and turn it back over to you, Megan, and let's see if there's any questions that I can help answer about these topics, because this is an important topic to be discussing. So Megan, I'll turn it back to you.
Yeah, thanks, Eric. I think everyone has the ability to unmute themselves if you do have a question, or there is a chat feature as well if you'd like to type something up, and we'll give it just a couple minutes, but feel free if there is a question, go ahead.
Yeah, I'll leave my screen shared here in case we want to see something. So Megan, if someone chats, will you read it and then tell me what the question is, please?
Yep.
So what questions do you have for me?
There was a
question
don't have one that came in before the call. They wanted to know when the sun's going to shine again.
Now that's a weather question, and here's the thing. We've had I have not enjoyed this winter one bit, right? We had the ice in central Illinois. It destroyed my trees. I have 15 white pine trees that have all been just ripped to shreds. We have not seen the sun in such a very long time. And it looks as though as we get into the second half of January through the front half of February, that we're going to ridge out Alaska, which means we're going to put a big ridge there in the jet stream, and it's going to dive into the central part of the United States, which means the chances of us continuing to stay cloudy and possibly snowy increase dramatically once we get past the next about 10 days. The next 10 days are dry. Yes, it's a bit depressing. And hey, we've made the turn though. We're past the solstice, which means we're gaining daylight hours, and spring will come and it's going to get here. If I could make a comment about that, let me see if I can stop sharing my screen here, and not stop sharing, but I'm going to share a website here for you. What I would like to make sure that you all do get to see here is, let's go to the latest US drought monitor. This should have been just updated while we were on this call, or maybe a little bit before. Yeah, this is how much drought we do currently have across the United States. And it did not change much from the last iteration released on December 31st. I will tell you this, if this drought picture does not change by April, I am very concerned about the spreading of drought across the primary corn and soybean belt. Usually I am not concerned about it at this point in the year, but this is the most drought that I've seen, where over 60% of the countries covered in it that I've seen in a long time. So this is not a repeat of 2020. That was an entirely, excuse me, not a repeat of 2012. It's an entirely different configuration, but it is something I'm concerned about.
So Eric, we had a question coming on the chat.
Sure.
Yep. So somebody's asking, knowing that, you know, we might see a longer growing season, but our days to get the crop in might be shorter to take it out. So should farmers be considering sizing up their equipment to be more efficient when they do have the conditions to go?
Well, so I'll answer two. One, I wouldn't be the person that would be able to tell you if that's exactly what I would spend money on. But I will say this about it. This is maybe the second part of it. I mean, the logical answer might be yes, but I would also say, look at what we did in 2018. So you remember 2018, April was record cold. Everything broke in May. And in the state of Illinois, when the window opened up, we planted at a pace of 400 acres a minute. We put almost our entire crop in inside of 2 weeks. I would want to have that as an option. In other words, when the window is there, I don't want to be waiting around on equipment. So if it's a sound investment and it is something that can be made without other economic consequences, by all means, do it. Because when we get the crop in, the world is watching. And therefore, for us to be able to do that in an efficient way, I think is critical. So yeah, that's a really good question. And that would be my response to it.
Great, thank you. Do you have any other questions from anyone that's on the phone or that wants to chime in?
Can I ask a question while we're waiting?
Yeah.
I'm curious if anything I presented today was surprising to anybody. In other words, did somebody see something today where they were like, holy cow, I didn't know that or hadn't heard that, or I'd heard the opposite of that. I'm just curious if someone wants to chime in and let me know, or I'll take silence as in, you know, Eric, it was fantastic. We were wanting confirmation of these things, and that would be useful to me as well. So what do you think? Anything surprising that I presented today?
We've had a couple questions come in while people are thinking through that. I think there's been a lot of great information presented. The first one, so you talked about carbon sequestration. Do you have a comparison of the amount of carbon sequestered from corn versus soybeans versus trees? I don't. But I know people that do, and I should ask them to get that question, get that paper to you. I cannot give you the numbers off the top of my head. You know, the difference between a tree versus, you know, our annual crops is that the tree is kind of it has 40 to 100 years of sequestration that it goes through, and versus you know, crops which are annual but are still effective at sequestering back into the soil. So no, I can't give you those numbers, but the fact of it is, just broad strokes here, we have to have production agriculture regardless. We got to grow the crops because there's demand for food, fiber, and fuel. And as a result of it, we need to start thinking about not necessarily how do we convert everything back over to trees because we need the farmland, but instead, what is the effectiveness, and are there changes in practices? Maybe those changes are around, you know, operational things like tillage or other things that could even sequester more carbon and prove that, because it's going to be something that's demanded by the modern consumer and then therefore paid for by the modern consumer. And I think that's a really, really fascinating thing that's going to be changing. So that was a roundabout answer to a very direct question, and I apologize, I don't have a more crystal clear answer for you. Not a problem. Next question. Are the 8 to 9 inch rainstorms going to persist? Unfortunately, I don't know why they would not. You're right. We've had some of these events that come through, and you just, you know, with the increase in, like I told you, precipitable water, with the uninhibited transport of moisture from the Gulf of Mexico that we can get in Illinois, you know, the atmosphere is ripe to do those things. And what's terrible about it is that sometimes those big rainfall events punctuate times of drought, and we can't even use the rainfall because it comes so much in one big helping that it runs off, which is why I'm very keen on learning about strategies by which to maybe better retain water in the soil through a lot of different soil health practices.
In fact, if I could tell everybody one thing, and this is why I told the story of Hugh Bennett, when I think about solutions to variability in crop production for the US farmer, for the Illinois farmer, I think it all ties back to soil health. Whatever we can do to maintain it is good for us and good for the soil and good for productivity. But that's still a question that unfortunately my answer is that we're going to continue to see big rainfall events.
And Eric, you kind of touched on this, and I'm going to skip a question to this next one because it ties in as well. But again, so talking about investing in equipment or tile, what type of priority would you place on investing in tile or other water management systems?
Sure. The most intriguing thing that I have seen in the last couple of years was the use of a saturated buffer. Is this group familiar with saturated buffer technology, Megan?
Some might be. We can definitely provide some more info when we share the recording.
Yeah, why don't I do this? I'm going to type in saturated buffer. Oh, perfect. Here's a good image of it. So good. This is a USDA article. Perfect. So I saw one of these going in 2019, and conventional tile drains out into your stream or ditch or waterway. And over on the Embera River, I saw them put in this saturated buffer system. So what they do is they put what they call distribution pipes down that run along the buffer, and these are big tile, and they bury them. Oh gosh, they buried about 9 feet deep. And the one that this guy ran was about 1,000 feet long. And so when the water came off the field, this little lock and dam system transmitted the water horizontally rather than letting it go out into the stream or ditch, or in this case, the Embera River. And the idea was to store that water in the nutrients rather than letting it run off, store it into the buffer strip on his land. What was interesting about this was, remember July of 19, it got dry here. We were super wet except for July. This guy actually had water stored in his buffer. He was able to open this, I don't know what it's called, but I call it a lock and dam system, opened it and let some of that water trickle back into his tile in his field. And that kind of tech, I believe he invested $10,000 in getting this system put in. But his yield advantage that year, because of it, far outpaced what he paid to have it put in. And I thought it was fascinating technology. I like investing in stuff like this. I would have to echo that tweet I showed you, that probably biggest ROI is making sure that the tile system you have is working properly. And if it's time to redo it in winter, do it, invest in it. By the way, this is just on the side here. After doing all this research about water, I invested in a company called WMS. They're Advanced Drainage Systems. They basically manufacture tile and drain culverts. And I bought stock in their company because looking at some of the statistics, I can only assume that their business is going to grow. And so far, it's been a good investment strategy.
Great. Well, Eric, we're just after 10 o'clock. I want to respect your time. We have a couple more questions. I don't know if you have time for them or if you need to be hopping off.
Yeah. No, I don't think my next thing is until 10:30. So, yep, go right ahead.
So the next one is, what part of Canada will see the most benefit from the additional rain, and will it be accompanied by an increase in growing season temperatures?
Yeah, great question. Follow Highway 16. You go all the way from Calgary clear over to Winnipeg. That district is going to see it. And, they grow a lot of cereal, small grains, and canola. And we've already started to see them increase soybean acreage. They've changed in other things as well. So I would expect that land to become quite a bit more productive. It's a little bit higher input, I think, than some of the land is here, like in the state of Illinois. But I believe that that's going to be the corridor. Also remember that between the Great Lakes and Ontario, that's another area that's seen some benefit here from change. That is also a highly productive area that I expect to see increases as well.
Great. And the last question we've got in the chat is, the Corn Belt's been moving northwest for several years. Is this trend likely to continue? And what would cause that to change?
Oh, good question. So the Corn Belt is moving north and west. And in fact, North Dakota, let me think here, North Dakota since 1990 has added 7 million acres of soybeans. So what is that? That's about half of an Illinois, more than half of an Illinois in terms of acreage. probably not in terms of productivity. There is nothing in the near term that I would say would reverse that trend. But what would have to happen is weather-wise, so let's pull out the markets, the supply, the demand of all of this, but weather-wise, what we would have to see happen here is that the rain shadow of the Rocky Mountains would have to expand, excuse me, farther to the east. I would be concerned about any increase in agricultural productivity west of the 100th meridian. And that's where I think it'll stop. I don't think it'll get ever past that because of the aridity that happens on that side of the rain shadow. So unless there's irrigation waters, like they have in the Ogallala Aquifer, to continue to irrigate, I don't think that there's going to be rapid expansion there. But to the north, I don't know why they would stop. And there is a lot of open land in the Dakotas that can be farmed or switched from other crops over to the big ones, corn and soybeans.
Great, thanks. And one final question came in at the last minute. So
Sure.
looking at changes in our growing season, do you think there would be an advantage to switching to a longer or shorter variety, or even into a different crop altogether?
I don't know that I could necessarily, especially in the state of Illinois, comment well on the switching to another crop. But, I mean, I asked a group, when was that, last year? I asked a group, I said, how many of you are multi-generational farmers? And almost every hand went up. I said, when did Grandpa used to plant a corn crop in Illinois? Middle to end of May. When did Dad plant corn crop? Beginning of May. When do you want to plant a corn crop? April 15th. You know, if you plant earlier, you can get more aggressive with the seed you use. And I'll be honest, seed technology blows my mind. The drought that Iowa had this year and the yields they got out of it, 10 years ago, 15, 20 years ago, they would not have seen anything close to that. So there is this option and opportunity that with these changes for folks to be more aggressive and to smooth out variability with all the tech that's in place and these long-term trends in weather that I'm talking about. So I'm already a half glass full kind of guy, but I'm very optimistic about the Midwest. And I don't want to be so blunt as to say this and have it come off the wrong way. But the Midwest of the United States, the Canadian prairie, and parts of South America are about the only places globally where I feel comfortable in saying that the impacts of climate change could have a net positive effect. The Western United States, Australia, parts of Europe, China, I can't necessarily say that I can find a net positive in those areas. I think that's just something that we need to think about and consider. And by the way, nothing that I said today is political. Nothing that I said today has anything to do with the way I think the industry should go, or even though I represent Nutrient Ag Solutions, this is just the scientific evidence that I'm presenting to you. This isn't, you know, necessarily all opinion and things like that. And I just think it's important for the industry to know these changes. And the industry, I am very proud of, is being extremely responsible with this and looking for solutions that make the lives of the farmer better and make the lives of the industry better. So I'm happy to be doing weather forecasting at this time, is what I'm trying to tell you.
Well, thank you so much, Eric. I think you gave us all a lot to think about and further some conversations after this webinar ends. Again, we were recording, and we'll post this when it's ready, so you can go back or share it with someone else who you think might find this information beneficial as well. And Eric, thank you again, and we look forward to having you again in the future.
Yeah, thanks so much.